Okay, we're going to graph using 3 points. Now if you remember when x is 0 from the coordinate system video, when x is 0 we have a point that lands on the y-axis. So if x is 0, then what we get is 2 times nothing plus y equals 5, and 2 times nothing is nothing. So our y value is 5, just like I already have written here. Now, what happens if x is 1? Well, again, we take 2 times and we replace the x with 1. So 2 times 1 plus y equals 5. Now, 2 times 1 is 2 plus y equals 5. And we have to finish solving for y. Since 2 is positive, it's been added to this side of the equation. The opposite of adding 2 is to subtract 2. So our y in this case is equal to 5 minus 2, which is 3. So we run up here to our table of x and y values, and so we have the first point here is 0, 5. The second point is 1, 3. You have to take them in the order that they're given. Now, when x is 2, we take 2 times 2 plus y equals 5. 2 times 2 is 4 plus y equals 5. Again, the opposite of adding 4 is to subtract 4. If we subtract it from one side of equals, we have to subtract the exact same thing from the other side of equals. 4 minus 4, chop chop, is gone, and we're left with y equals, and then 5 minus 4 leaves us 1. So again, we come up to the table and we fill in the y value, which is 1. Now we have the point 2, 1. How are we going to graph this? Well, first off, we draw a coordinate system where we have an x-axis labeled and a y-axis labeled. Then, for the first point, we go to x equals 0. Remember, if I go to the right, x is positive. If I go to the left, x is negative. So for x to be 0, we have to stay on the y-axis. So then for our second value that we have to graph, y is positive 5. So we go up 1, 2, 3, 4, 5. And this is our first point that we graph. Now for the second point, x is positive 1 and y is positive 3. So we go to x is 1, and then we go to y is positive 3. So 1, 2, 3, and we put a point at the crosshairs. Then for this last point, we go to x equals positive 2. So 1, 2, and then y is positive 1. And we put a dot there. Now when we graph, we don't just slop a line on to the graph that connects those points. We take a straight edge and we line up the dots, and then we make our line. And normally we don't go very far past our first dot and our last dot, although I did go pretty far past this one. But normally we just go a little bit beyond each of the outside dots. Now, for another example, we've got negative 5x plus 3y equals 15. First, we're going to let x equal 0. And I'm going to take a shortcut. As you saw, 2 up at the top, 2 times 0 was 0. So that whole piece went away. Well, that's what I'm going to do with this. Negative 5 times nothing is nothing. So that part of this equation goes away, and all we're left with is 3 times y equals 15. The opposite of timesing by 3 is to divide by 3. And if I divide on one side by 3, I have to divide on the other side by 3. And that gives us y is equal to 5. So I have the ordered pair 0, 5. Now I'm going to do the same thing here. When y is equal to nothing, 3 times nothing is nothing, and it goes away. What we're left with is negative 5 times x equals 15. When I divide, because it's times, the opposite of timesing is to divide, and you take the sign with it. So you're dividing by negative 5 on both sides of equals. That gives us x equals, well, positive divided by a negative gives us a negative. So we get negative 3. But this one's x. So I go to my x, and where I had y equals 0, I put next to it x equals negative 3. So it gives us the ordered pair negative 3, 0. Now the last point we're going to graph on this one is x equals 3. So now we say negative 5 times positive 3 plus 3y equals 15. Negative times positive is, you're right, negative. So negative 15 plus 3y equals 15. And I've run out of room, so I'm going to come over here a little bit. Negative 15 plus 3y equals 15. The opposite of subtracting 15. So yes, we want to get anything added or subtracted to our y. Get rid of it first. So the opposite of subtracting 15 is to add 15. And if I add 15 on one side of equals, I have to add 15 to its like term on the other side of equals. If you owe 15 and you pay 15, you don't owe anything else. So 3y equals 30. Now the opposite of timesing by 3 is to divide by 3. And our y value here equals 10. So now we have the ordered pair 3, 10. Then we're going to graph this. How do I do that? Well, first I have to have a coordinate system. And I have to have an x-axis labeled and a y-axis labeled. So I go to x equals 0, then y equals 5. So 1, 2, 3, 4, 5. And I put a point there. Then I go to negative 3, 0. So x equals negative 3. 1, 2, 3. And y is 0. So it doesn't move up or down. It stays right on the line. Now to go to positive 3. 1, 2, 3. Hey, guess what? 10 is not in my graph. So actually in this case I'm only going to use these 2 points. And again, we have to line up the dots with a straight edge and not just slop a line on there. And make sure our line hits our dots. Make sure there are arrows at the end of our line. Questions? If you've got any, please ask me in class, because I would be glad to help you. Now, the last one we're going to show on this one is y equals 3x. This is not in standard form. This is in slope-intercept form. Excuse me. Since it's in slope-intercept form, I can basically use anything I want for x, because I do not have a fraction in front of my x. So I'm going to let x equal 0, and so y equals 3 times 0, which gives me 0. Do you remember what the ordered pair 0, 0 is called? You got it. It's called the origin. Now I'm going to let x equal 1. So y equals 3 times 1, which just gives me 3. And then I'm going to let x equal 2. So y equals 3 times 2, which gives us 6. So now I'm going to graph our ordered pairs. 0, 0, which is there. Then x equals 1, y equals 3. Then we go to x equals 2 and y equals 6. So 4, 5, 6. And again, we use a ruler or a straight edge to line up the dots. Again, don't go very far past the outside dots, and make sure you finish the line with arrows. This is the end of the first part of your graphing with 3 points.